best example of what I'm trying to explain. So there's no one textbook. So Beer and Johnson is one. Hibbeler is another one that I use. Okay. And another few other more. But some of the textbook I use are very old. Okay. So it's those old textbook they are better than the new one. The new one are just pretty pictures. Okay. Unfortunately. Right. Let's look at another example. Let's look at this one. Okay, let's look at this one. Okay, let's look. This one's like, whoa.
Eugene,
Yes.
is it okay if you could post practice questions so we could study for our test?
Homework are all your practice question,
Okay.
right?
Yeah.
Does that make sense?
Yeah.
Okay. Right. So you have this question now, okay? This question is yeah. Right. So this question states that the build-up timber is subjected to 150 pounds vertical shear. Knowing that the longitudinal shear of the nail is the spacing is 2.5 inch, and the nail is 3.5 inch long. Okay, this is just to tell you that the nail it goes through the wood. Okay, determine the shearing force in each nail. Question for you: how will the length of the nail help you? Okay, let's look at experience. I want you guys
To know how far it goes into the one in the middle.
Yeah, so what? Is it important? That's what I'm
Not
trying to say.
really.
To know whether it's double shear or single shear.
Yeah, no, this will not work. Also, it's nothing to do. So, some of you are in civil engineering now, right? So you use a longer nail, a shorter nail. Okay, as long as the nail goes through the part you're holding, you're fine. There's a certain limit, yes or no? There's a certain limit of nail that you need. But if you use a nail that is much longer, okay, than the optimum, what will happen? Will it help?
It'll
Anyone?
stick out.
It will not help at all because what will help is the what? The resistance force, right? What will help is the resistance force. Okay, as long the nail penetrate to the parts that you're holding, you're fine. You have to make sure that happen. If your nail is not long enough, that's where trouble will come in. So we know when they say 3.5 inch, we know that okay, the nail goes through what? Goes through the centerpiece also. That's all. It will not help you. Okay, it will not help you in the strength of the structure. It will not help you. Why do I say that? Anyone can point out why do I say that? Why is that statement made? Show me a formula now that we have applied that has the length of the nail in the formula. Anyone? Can anyone show me any? None.
It's based on the cross-sectional area, and that's
Yeah.
it doesn't matter as the area is the same.
Well done. There you go. You know what? I did not know that until I taught this. I thought, okay, if this is pulling out, okay, sunshine, let's go to Home Depot, buy a longer nail. Dum, 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 dum. Does not help. You are better off buying a what? Buying a bigger diameter, yes or no?
Yes.
There you go. Am I right? Now, you are looking at someone that has never built a deck. Most of you have built a deck. Am I right?
Yep.
Yeah, right? There you go. So that's the beauty of what I hope you all appreciate. That's why I'm so keen in this topic because I'm seeing things that I'm not seeing. I mean that I did not know when I was undergrad. Okay, I want to transpose all to you now. Okay, all this knowledge and it's so important. Okay, that's the drive. That's why I'm teaching this course and not giving up on any of you. Okay, right? So that's why when I seen this question, like, what is this? Okay, we never had any formula that has the length of but there's an optimum length. Okay, you need to reach that optimum. Okay, how to calculate that optimum? I don't know yet. Okay, right. So determine the shearing force in each nail. Okay. So we know that this is subject to a vertical force, 1500 pounds. I'm not going to go through the calculation of the second moment of area. I'm just going to write out the value. I will leave you to calculate that. So IZZ. Okay, so if we were to use this configuration, so this is Y, this is Z, this is rotation about X. Okay, so so IZZ is equal to 712/3 inch to power 4. Okay, then this is my centroid. Right. Right. That's my centroid. And then this is our datum. This is our analysis direction. Right? Now, question. We know that the formula is equal to Q is equal to VQ over I. V we know, I we know, Q. What is the Q? Anyone? Is Q calculating 1, 2, and 3? What is it?
I think it's only the first.
Wouldn't it be calculating one is the flange?
Yeah, you are spot on. Right? Because if the analysis start from outside, when you move your slider, right, once it pass here, this area is past the slider already, yes or no? It will become what? Constant. And that is the shear force that would be transmitted to what? This area will transmit the shear force to the what? To the fastener. Does that make sense? Yes or no? If your slider is here, right? If your slider move to here, you don't need to analyze this at all. Why you don't need to analyze that area is because I should not use the same color shoot. Okay, let me wait. You don't need to analyze. So once your slider is here, let's say now your slider is here, you don't need to consider this area at all. You don't need to consider this area. Okay, the area color in green. You don't need to consider that area at all because the fastener is the one that's going to transmit the load, and how much load it will transmit is depend on the first moment of area of block number 1. So now it becomes simple to you. We just apply rule number 1, 2, and 3. Yes or no? Right? The rule number 1, V and I are constant. Rule number 2, that the analysis the analysis is from the datum. Rule number 3, the datum is at the centroid. Rule number 3, the analysis will start from what? Y max. There you go. You never get wrong. Okay, that's why I say those 4 rules apply from the very beginning up to the end. Okay, so now from here, some of you say, yeah, can I'll show you. Okay, so Q. Okay, for member, so Q in Z for member number 1 is equal to A Y bar. So the width is equal to 2. The depth is equal to 4. And the Y relative from the centroid is equal to 6 divided by 2 is equal to 3. Okay, so 2 times 4 times 3. So 2 times 4 times 3 is equal to 24 inch cube. Okay, so now We calculate Q. V is what we want to, no, V is 1500. Q is 24. I is equal to 712/3. So your Q over here, so 1500, that's by 24 divided by 712/3. So it's equal to 13500 over 89. Now this is in pounds inch. Okay, so I'll do again 1500 times 24 divided by 712/3. So it's equal to 13500 over 89. So then the Q will be equal to, so I'll give more space. The Q is equal to 2, right? So why 2? Because you have what? You have one screw over here, 2. Okay, so the 2 is for left and right nail. Okay, so 2. So this is the F, the resistance force of the nail that we want to find out. Divide by the spacing that is equal to what? Spacing is 2.5. Right? So this will be equal to 13500 over 89. So the force resistance of the nail per nail is equal to 13500 over 89 times by 2.5 divided by 2. So it's equal to 189. Okay, 189.61 pounds of force. Or you can round it up to 190 pounds of force. Okay, you cannot measure 0.61. Right? You can see, right? It looks like really complicated, right? But when you apply the rules, right, it's so easy now. Okay. Any questions for this? Anyone? No? Okay. Yes. I hear a click. No? Okay. Let's look at another example. Okay, let's look at another example. Now you guys were. Okay, so I want you all to look at. Okay, let's look at this example. This looks like really hard, but it's not that bad. So hold on. So this is example 2. We have just done example 3. Now we're going to do example number 4.
Hey, Eugene, there's a
Yes.
question in the chat. Why is the centroid 6/2? I started thinking about it. I'm wondering that too.
Okay, so why the centroid is 6/2? So let me get rid of this. I shouldn't have done that. Wait, my bad. Okay, so let me copy and paste. I think I did it too quick. All right. So when you see over here, right? So this is where the centroid is. All right. So the distance from here to here is what? So the distance from, wait. So 6, or maybe I got it wrong. Hold on. Did I wrote wrongly?
It is 6.
So this is the centroid over here, right? This is the centroid over here, right? For the center bar, right? So from here to here, from here to here. So from here to here is what?
3.
3,
3.
right?
Yeah.
So from here. Why do I? Yeah. So 6 divided by 2 is 3.
Shouldn't it be plus the half of 4, so it would be 4.
So here to here is 1. Here to here is also 1, right? Hello?
Yeah.
Right? So here to here is 2, right? Okay, I